Right? In some cases, it may be to our benefit. Instead of organizing our frequency distributions with each different individual data value as a row in our table, we might want to create frequency distributions that organize data into groups. Those groups that we're going to put our data in are called classes. Right? The width of each of these classes is the same. It is often suggested that a frequency distribution should be constructed with 5 to 12 classes. This size shows detail and also maintains clarity. If we end up with too few or too many classes, then we kind of start to lose either some of the detail or it becomes a little bit messy and we lose some of the clarity. Right? So some more definitions here. The lower class limit is the smallest value within the class. The upper class limit is the largest value within the class. The class width is the difference between two consecutive lower or upper class limits. So difference meaning a subtraction. The modal class is the class with the greatest frequency, and we'll see the word mode again in the next section as well. The midpoint of a class, also called the class mark, is found by adding the lower and upper class limits and dividing the sum by 2. Right, so we're going to go through and we're going to use our same raw data set that we used in the previous example, and we're going to find a slightly different frequency distribution where we have our information organized in classes. All right, so first thing that we're going to do is we're going to go through and enter our number of athletes for each one. So 9 to 11 goals. We have 1, 2, 3, 4, 5. Right, 12 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9. 15 to 17. 1, 2, 3, 4, 5, 6. 18 to 20. 1, 2, 3, 4, 5, 6. 21 to 23, we just have 1. We don't have any for our next few classes. 33 to 35, we also have 1. Again, if we were to total this like we did in our previous distribution, we also get a total of 28. All right, so use the data to construct a frequency distribution with classes, and then we're going to use this frequency distribution to determine the total number of observations. Well, we added that up. We got 28 observations total. Again, we could count the number of values in our original data set or simply add these up. That gives us our total. The width of each class. The width of each class, remember, is the difference between two consecutive lower or upper class limits. So what I'm going to do is I'm just going to take these first two lower class limits and subtract those. So 12 minus 9 gives us 3. Notice that if we were to take 14 minus 11, if we were to take our upper class limits, that would also give us 3. And if we were to take any of our other pairs, 18 and 21, 21 minus 18 gives us 3. So it doesn't matter which pair of data values we pick. When we subtract our consecutive lower or upper class limits, we get a difference of 3. Right, our midpoint of our first class. So our midpoint is found by adding the lower and upper class limits and then dividing by 2. So our first class, our lower and upper limits, right, 9 and 11. We're going to add those and divide by 2. 9 plus 11 gives us 20. 20 divided by 2 gives us 10. That's also referred to as our class mark. Looking at our data set, we can easily see that 10 is the number that comes in between 9 and 11, but if we have larger groups of data, this can be something that could be useful for us. The modal class or classes is the one that has the greatest frequency. Our greatest frequency is the 12 to 14 goals because it has a frequency of 9. So our modal class is that of 12 to 14 goals. Right, the class limits of the next class, if an additional class were to be added, Well, we're going to take these class limits that we have here and add 3 to both of those. So if we add 3 to 33, we get 36. If we add 3 to 35, we get 38. So we take our class width and we add that to our previous class that we just had. That would be our next class that would be in that table. So if you're given a frequency distribution, or if you're asked to construct a frequency distribution with different classes, you may be asked to do some different interpretations or come up with some different information based on the frequency distribution that you then generate.